Hello students, here we are discussing about calculation of effective resistance. In the calculation of effective resistance, so first one for the resistance combination, series and parallel combination, and next one is the resistors will be connected in different circuits in different modes, okay, different methods like. Most of us are facing the difficulties to solve the problem, okay. So we need to follow some methods for the problem solving, that is calculation of effective resistance. So for the first one, calculation of effective resistance is what? This very first one is that, so method of successive reduction. First one, method of successive, so successive reduction. First one is about method of successive reduction. Okay. So one by one briefly I'll discuss. Okay. Next one is about equipotential points. Say equipotential points. So for the equipotential points means what? Electrical symmetry. Say electrical symmetry. Electrical symmetry. And next one is about the method of symmetry. Method of symmetry. Yes. So for the problem solving, first one, method of successive reduction. Successive reduction means what? If you identify the resistors connected in the circuit are either in series or parallel. Okay. So if you identify, so identify the resistors are in a series or parallel combination. If they are in series or parallel combination. So then next one about this successive reduction means what? Combine the resistors. Combine the resistors. So combine the resistors means what? We can use, if they are in series, R is equals to R1 plus R2. If they are in parallel, 1 by Rp is equals to 1 by R1 plus 1 by R2, so on. So this is what a method of successive reduction. And equipotential points. Equipotential points are the points which have equal potentials. So the points which have equal potentials can be joined. Okay. So then by using this one, we can solve the, so we can simplify. Okay. So we can simplify the circuit. Method of symmetry. In this method of symmetry, we can use about many different types of methods are there. So different people will use different methods like, but for all the students, if you use any method, whatever that, you are getting the same answer. Okay. So this method of symmetry, in this method of symmetry, first one is about, I can say like folding methods. Folding methods means what? Parallel axis symmetry. Okay. So parallel axis symmetry, perpendicular axis symmetry, okay. So perpendicular axis symmetry. So next one is path symmetry. Okay. So next one is path symmetry, like so shifting symmetry means what? Shift symmetry, like different methods we can use it as. Okay. So for the problem solving, anyone we can use on this. So these are the methods. And next one, So first we can able to identify that the resistors are connected in series or parallel. If they are in series or parallel, if you able to identify, we can use method of successive reduction. Okay, so I'm going to discuss individually one by one. So for the first one is about method of successive reduction with an example. A method of successive reduction is the first method. Okay, the successive reduction, first one we should know about that. Okay, so in this method, so what must we know? In this method, if you able to identify the resistors are connected in series or parallel, okay, by using the related formula, so we can simplify the circuit. And in this method, resistors are combined, okay, so one by one combined to get the equivalent resistance. If you can identify, you can identify the resistors are in series combination or parallel combination. In this method, so resistors are combined. Resistors are combined. Resistors are combined. Okay, to get a resultant resistance. To get the resultant resistance. Okay, so just successive reduction means what? Two are combining or three are combining. They are while taking their effective resistance, we can use this is what? Successive reduction. Let us take an example. First one, there are the how many resistors are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 resistors we have here. Okay, so we have the 9 resistors. And now let it be, this is positive terminal and next one this is the negative terminal. So current is what? It's a splitting like this. Yes. So my method, I should able to identify that. So which two resistors are, which three resistors are, which resistors are in series or in a parallel combination. Okay. So if the resistors are in a series, for example, these two are in a series. Why? Because same current is passing through this. So what is the equivalent? R plus R would become as, it's a 2R. Equivalent resistance is what? It's a 2R. Okay. So now we can see this 2R and 2R will be in a parallel. Okay. So next one is that 2R and 2R are in a parallel. Okay. So 2R in parallel. You know, R and R are parallel, effective resistance R by 2. Okay, 10 and 10 ohm and 10 ohm resistors are in parallel. Effective resistance is what? 5, 10 by 2. So 2R and 2R are in parallel. 2R into 2R by 2R plus 2R. What will be the answer? It's a R. Okay, so this circuit would become as, so for the first one is this. So these two are combined. This is what? It's a R. 2R and 2R become as what? It's a R. Okay, so next one, this I'm taking as it's a R. So it's as usual, this is 2R, and next one it's a 2R. Okay, here R is here. The next one is that this is R. So here is the R. Okay, so this is what? X. The next one is it's a Y, right? So now, and the same situation. So now, and successive reduction, I can able to identify these two are in a series. So series means what? What is the R equivalent? It's a 2R. 2R and 2R in parallel. These two are in parallel. So what will be the answer here? 2R and 2R means what? It's a R. Because 10 into 10, 10 plus 10. Okay, means what? It's a 10 by 2. It's a 5. Yes. So this is what now, while taking this is 2R and 2R and 2R will be parallel. So 2R into 2R by 2R plus 2R will be what? It's a R only. Up to where? Here. Yes, up to this one. So these two are combined, so to form as 1. 1 means what? First I'm taking as this to this will be from here to this. I am taking as 2R, and 2R means it's a R. So next one, this will be R, and next one is, this is what, it's a 2R. Next one is, so this is, it's a R. Here also one resistor is there, R. Okay, so is a case, it's what, X and Y. So now we can identify again successive reduction is taking place, R and R. Okay, so these two are in a series, 2R and 2R in parallel, right? Again it will become as a R. Okay, so how can I take this? For first one is first resistor, I am taking as this, it's a R. Okay, so next one, this is will be R, correct? So it's a R, and this is what, it's a R, correct? So these two over, and R plus R become as a 2R. 2R and 2R will be in a parallel, means it will be R. Okay, so this R written, next one, this R is here, so next one R, this is X, and next one is what, it's a Y. Okay, and again successive reduction is taking place. R plus R is 2R, 2R and R. Yes, so 2R and R. So finally it became as what, like this. This is R. So here we can say it's a 2R. So what do you say? This will be, so I am drawing one more circuit here. So it's what is a effective one, right? So this is what R equivalent. So what is R equivalent? So 2R into R by 2R plus R. It's a 2R square by 3R. It's what? 2R by 3. So finally this total is clubbed or combined to form as a single one. This is what R equivalent. So R equivalent is what? What is R equivalent? 2R by 3. So now R equivalent is equals to 2R by 3 is your answer.